In this lecture, we will look at what are routers, bridge, switch, repeaters, and hub. They are the things that are asked so many times in your interviews. So let's try to look at what routers, what are bridge and switch, and what are repeaters and hub. So for just looking at it, so routers are at the network layer. Okay, so they are connecting device at the network layer. Bridge and switch are connecting devices at the data link layer, and repeaters and hub are interconnecting devices at layer physical layer. Okay, so now let's try to see in detail. So let's look at first what is repeater. So repeaters were the first thing that were invented, okay, for making the LAN remove the distance limitation. Okay, so what does that mean? So initially, let's say you have a university campus. So in building A you have some computers, okay, and then in building B you have some computers, okay, but I want that those are on the same local area network. But the problem is, if this distance is big and the signals which are coming here over the wire, they will start attenuating. Okay, so they will become weaker as they travel over the long distance due to attenuation. So that happens with electrical signal. So this imposes a limit on the length of the LAN, that okay, how far, what can be your maximum length of your wire, because of degradation of the signal as the distance increases. So what was the solution? It was that repeaters now join two LANs. So here this distance is very far. So what I do? I connect it with a repeater. And what will a repeater do? So it will have my signals again repeated with refreshed. Okay, so let's try to see that thing. So we will look at, so for example, what happens here is, so if you have a repeater, okay, and your signals are coming, so signals have become little weaker. So those pulses will now become like this. So they are kind of repeated with much more power, okay, so that it can be directly identified that this is 0, this is 1. Over time, if this was getting weaker, this signal, it would have become like this, and it might have become below threshold, so 1 would have looked like a 0. So repeater reshapes the pulse and repeats the pulse basically and makes it 1. And similar to repeater, we also have hubs. So here in repeater, you just have one wire, okay, one Ethernet cable, and the signals on them were getting repeated, okay, refreshed and then coming out. But what happens if I have a wire and I want that, okay, it should be coming out of different, same thing, whatever signal is coming here should be repeated on 3 different wires. Okay, so the LAN now can be like on this building, in this building, and in the third building. So as you can see here, so this is one LAN, this is the same LAN part 2, this is the same LAN part 3. Okay, with the hub, now what happens is that the signal comes here, okay, so they are forwarded to all these 3 wires, and here it also acts as a repeater, also acts as a hub. So these whatever signals they were becoming weak, so they now become repeated and they are refreshed, okay. And then what happens is these hubs again now, so this is a kind of star network where multiple wires are coming out, but all of them are having the same signal. So if whatever is coming, it is now repeated on all the 3 wires coming out, and then these hubs again catch this, and except from where your signals are coming, it will forward it to all other wires going out of the hub. So designed to hold multiple line cards, and they don't amplify the signal, they just repeat the signal with proper that curve, okay. And also operates at the physical layer. So moving forward, so what are the limitations of repeaters and hubs? So one large shared link. So one of the problem is they have a shared link. Each bit is sent everywhere. So what happens is whatever bit, so this is a hub, whatever is coming here, and it has, let's say, 3 outgoing ports. So these bits are going to be sent everywhere. So aggregate throughput is limited. For example, 3 departments each with 10 Mbps independently and then connected via hub must share their 10 Mbps. Okay. Cannot support multiple LAN technologies. Okay, so they are just repeating the signal. Okay, so they don't buffer the whatever frames are coming. Okay, they don't interpret. So can't interconnect between different rates and formats. So if some format is there, so they cannot change the format because they are doing nothing with the frame. Now let's talk about bridges. Okay, so what are bridges? So bridges are now so repeaters were at physical layer and they just did not check anything. Whatever was coming from one port, it was repeated at all the other ports. Okay, but they were not smart. So now bridges are smart MAC layer device or data link layer device which connects 2 or more LAN at the link layer. Okay, so they are now connecting 2 or more LANs. So what is becoming there? This is one particular LAN. Okay, this is another LAN, and both are connected by a bridge. So this is one port with which LAN 1 is there, and with one port LAN 2 is there. So now it processes the packet also. It looks at the packet and sees what is the destination, and only, so let's say this host sends packet which is the destination also resides in this LAN 1. So in this case, when the bridge sees this, it will not forward this packet to LAN 2 because it knows that, okay, the destination of this particular frame is in LAN 1 itself. Okay, so it looks up the destination in the table and forwards the frame to appropriate LAN segment. So when it knows that the destination of that particular frame is here, it will not forward it to LAN 1. Only if the destination is here, it will forward. And each segment can then carry its own traffic, and there will be probability of less collision because you are not just forwarding packets to different LANs without seeing if that particular packet will belong here. Okay, so this is there. So this is quite advantageous. Okay, because now you're not having a lot of collisions. So link layer. Now let's talk about switch. Okay, so what are switches? But let's try to look differently. Okay, so we will look at here. Okay, let's try to see. So we come to a bridge. Okay, so a bridge, what we were seeing, it maintains a table for decisions. So let's look at those decision making table. So we have now a bridge which is connecting two LANs. Okay, so it has 2 ports. This is our bridge and it has 2 ports. LAN 1 is connected via port 1, LAN 2 is connected via port 2 to this bridge. And let's assume that for now this LAN 1 has 2 machines on it and LAN 2 has also 2 machines, and these are the 48-bit MAC address. So now what it says that it has a table which says that, okay, if this is the MAC address, then you forward it to port 1. So for example, LAN 2, let's say this machine sends frame to this one. Okay, so that bridge will have a lookup here. So it's 71 to B 1345 61 41. So what will it do? It will see that okay, this is in port 1, so it will forward it to port 1. Okay, so this way it helps. And if it was just to, let's say, that 61.12, this particular computer, then it will find 61.12. okay, this is in the same LAN 2 and it will just forward it to port 2. So it will not go out to LAN 1 and it will not cause unnecessary collision. Okay, so this is the beauty. A bridge does not change the physical address in the frame. So it does not change the address, it only makes a lookup for it. Now let's look at, so do we have to fill that particular table which we were looking? So it's quite difficult, isn't it? So now that's why we want the process of making the table to be automated. So here is the learning process for the bridge. So let's look here. So we have a bridge here. It has 3 ports and the 3 LANs are connected to it. So LAN 1 is on port 1, LAN 2 is on port 2 and LAN 3 is on port 3. Now how does the learning takes place? So what happens is, let's say that A sends a frame to D. Okay, so A sends a frame to D, it comes to this bridge, and now initially when the table is not filled, so what will happen is that it will look and it will find there is, it doesn't know where to send D2. Okay, so it doesn't know which port D belongs to, so it will forward it now to port 2, port 3, and it will not forward it to port 1 because it is from there the packet frame is coming. But what it knows that the source of this frame is A and it is coming at port 1. So now it writes in the table that okay, A is the at port number 1. So next time when, let's say, F sends a frame to A, it can easily know that okay, A is at port 1. So this, now it doesn't forward it to both 1 and 2 but only to port 1 because it now knows that A resides in port 1. Now let's say second time E sends a frame to A. So E sends a frame to A. E is on LAN 3 which is at port 3 of the bridge. So again, based on the source address, and if because it's coming at port 3, it knows that E is on port 3 and it puts it on its table. And then now it also knows that A is at port 1 of the bridge, so it forwards the frame to port A. Similarly, if B sends a frame to C, okay, so it knows that B is at port 1. Okay, this way the learning happens, and after some time when mostly all the nodes have sent some message of frame, then they will have their table here. Okay, and if somehow one new source is there, okay, for which the table is not filled, so then it will forward it to all the ports. So this is how the learning takes place. But there is a problem. Okay, what happens is, for reliability and fault tolerance, many people, administrators, okay, what they do, they have 2 or more bridges for fault tolerance and reliability, but that causes a loop. Okay, so let's try to see what is a loop. So here what happens is, let's say this is LAN 1, there is a bridge 1, bridge 2, 2 bridges are there, and administrator wants to make sure that okay, where even if one bridge fails, our packet should be, frames should be moving around. So if this fails, then also packets frames can go to CND LAN 2. But what will be a problem? The problem is of loop. So A sends packet frame to D. Then what happens? It comes to bridge 1 because it is received by bridge 2. and both of them now sees that okay, the source is A, so they put in the table, bridge table, that A is coming from port 1. So far well good. And two copies of one from bridge 2, one from bridge 1 comes to LAN 2. Now what happens, from bridge 1 the packet frame comes, it travels to D and C, but because bridge 2 is also on LAN 2, it goes, that packet from A goes to this one also. And now again the source is A, okay, the frame source is A, but now it is for bridge 2, this is coming from port 2, and frame from bridge 2 also went to bridge 1. And now even though the source is frame A, source is A, it is coming from port 2. So now it updates its address as address A is coming from port 2. So this becomes a problem, and then it passes on the packet to the frame to LAN 1. Then what happens? Again it sees that okay, destination is D. So one frame comes here and it says okay, the destination is D. So it comes here, but what happens is that again it updates that okay, from A, the port now from which it comes is A1, and this keeps on continuing. So a loop is created. So we need to see this problem. And what is the solution? The solution is spanning tree. When we have multiple bridge, for reliability we have spanning tree algorithm we apply here. And then what happens is, let's say this is the LAN 1, LAN 4, 2 and LAN 3 are connected by 5 bridges. Okay, so this is very good architecture based on for reliability, that even if this fails, then also let's say between LAN 4 and LAN 3 both of, okay, so what happened, okay, both B5 and B2 fail. Then also if you see, even if this fails, LAN 4 can go via B4 and then B1 to LAN 1. So this is very reliable architecture, but the problem is we might have a loop. Okay, so this is a loop, this one is a loop, this whole thing is causing a loop, and loop is not very preferred because then endless packets are frames are moving around. So what we do is we make, these are now nodes, okay, of a graph. So this is LAN 1, LAN 2, so these we make, and then what happens is we make a graph out of it, and then what we do is that in this graph we find a minimum spanning tree. Okay, so the minimum spanning tree for this particular graph, which was of bridges and LANs, is this one. So now here we remove this edge. B3 is now not connected directly to LAN 3, it's not connected to LAN 4, and B5 is not connected to LAN 3, and this was the root of spanning tree. Okay, so now what happens is, and still the important thing is all the LANs are connected. Okay, so LAN 3 is connected to LAN 1 also, and the hop distance is 1. One bridge is needed for the connection. LAN 3 is connected to LAN 3, but now it has to go via B2 and B1. LAN 2 is also connected to LAN 4 via B4, and so on. Okay, so all of the LANs are still connected, but there are no loops, and that is the benefit. But now you will say that okay, if this will fail, bridge B2, then again we will have a problem that LAN 3 will now get disconnected from all. But then what happens is, even though there is a spanning tree, it's not a physical, it's a logical spanning tree. Okay, so then they keep on checking, if this gets disconnected, I will put this port on and this connection will become fine. Then LAN 3 can connect to LAN 2 and LAN 1 via B3, it can also connect through this link. Okay, so it kind of keeps checking which link has failed. So what is it called? These ports are now called blocking ports, which are by this dash line. Okay, so these are blocking ports. So forward packets are not forwarded for port 1 of B5, port 2 of B3, and port 3 of B3. Okay, so this is how it happens. So this was about bridge. Now let's look at something more. So we have also switches. So we have switches, and switches also are like bridges, typically connect individual computers. Okay, so now what happens is a switch is essentially, it's also same as bridge, though typically used to connect hosts and not LAN. So they connect usually the hosts and they are not for LAN. So now A, B, C and D are connected via switch, and what is the benefit is it can support concurrent communication. So A can talk to C, and at the same time D and B can talk with each other. Okay, so that is the benefit of switch. So we have dedicated access, host a direct connection to the switch rather than a shared LAN connection. Okay, it's full duplex and completely supports concurrent transmission. So that is important for a switch, which might not have been there in a LAN. And then it also, bridge and switch helps in traffic isolation. So what is traffic isolation? So let's say we have a switch here, we have segment 1, this one is segment 1, segment 2. So what they do is, if a packet is here in this segment and it sends this to this particular segment 1 frame or packet, then only it will be forwarded to this one and not to the other hub, so that collisions happen. So it's a kind of packet filtering happens here. And advantages of hubs over hubs and repeaters: only forward frames as they are needed. Okay, extends to geographic span, improves privacy also. Okay, so disadvantage, what will be the disadvantage? When we are processing the packet, okay, we are parsing the frame and looking up a table, it adds to the delay. So now I hope you understand the difference between repeater, hub, bridge and switch. And next thing is we need to learn about router, which we will do in the next class. So thanks a lot.